Hello everyone, in today's video we are discussing about the relaxation oscillator. So relaxation oscillator is taking non-linear electronic oscillation that generates a continuous non-sine waves which will give us the output in the form of rectangular wave and the triangular wave. The time period of the sine wave and output depends on the charging time of the capacitor connected in the oscillator. So what we are doing, we are connecting the capacitor here. So this is used for charging time of the capacitor. Whenever the charge is more, it will be in a UTP. When the charge is discharging, it will get down into the LTP. The relaxation oscillator is basically contains a feedback loop that has switching device in the form of transistor. So here we have connected the capacitor. So here we can say when capacitor is discharging, it will go to the LTP. When the capacitor is charging, it will go to the UTP. So similarly, we have given our positive feedback with the voltage reference. So we call this as a voltage reference to parallelly connect it to the voltage output. So for similar circuit, when we get the output, so when the capacitor is charging, it keep on charging, it will keep on staying in the UTP level. When the capacitor is start discharging, it will start discharging. Once it reaches to the 0, then it will go to the lower triggering point. It will fully discharges and it will go to the lower triggering point. When the capacitor is again charging, it will start increasing till it go to the 0 point. It will start charging up. Once it crosses this 0 point, it will charge and go to the UTP level. So here we are checking in relaxation oscillator, we are checking the time period from starting point to the end point till what time the relaxation of that sine wave is happening. So here, assuming that output is initially in positive saturation, we can say at non-inverting terminal we have given input and triggering points are also at the non-inverting terminal. We will get similar to our schemic trigger, will get UTP is equal to resistor 2 divided by resistor 1 plus resistor 2 into plus Vsat saturation, because UTP is nothing but we are taking some part of the sine wave, we are not considering whole sine wave. So instead of V0 we are placing plus Vsat, and LTP is equals to resistor 2 whole divided by summation of resistor 1 and resistor 2 minus Vsat. So till capacitor is charged fully, it stays in UTP, and as capacitor start discharging, it starts slowly downing to LTP, so it goes to minus Vsat. The charging and discharging of capacitor will change output from two different saturation point, that is UTP to LTP. So T is nothing but your time period across the resistor and capacitor while charging. Now we'll get voltage capacitor is equals to voltage of maximum time period plus voltage at initial minus of voltage max given by e raised to power minus T1 whole divided by capital T. Instead of capital T, you can use RC value. So voltage capacitor at what it is doing, the sine wave is in UTP value, so it is in UTP, so we consider it as a UTP. So we'll get UTP equals to V max. When UTP value is in upper the 0 triggering point, we'll get plus Vsat plus of V initial is nothing but our LTP, because starting it was at 0, so we'll get LTP minus Vsat e raised to power minus t1 whole divided by rc. In place of t, I am replacing this rc value. Now I can take LTP minus Vsat into e raised to power t1 by rc, which will give us Vsat minus UTP. Next, I can return this back, T1 RC, Vsat minus UTP whole divided by. So here we'll get minus value, so we can take this as plus Vsat minus LTP, which will give minus T1 by RC. This E logarithm I am transferring as logarithm of Vsat minus UTP whole divided by Vsat minus LTP, which will give minus T1 equals to RC into logarithm of Vsat minus UTP whole divided by Vsat minus LTP. This T1 I can, when I am giving to logarithm, what will give us? It will reverse the ratio. Ratio means this Vsat minus LTP whole divided by Vsat minus UTP. This ratio will get reversed. So here we can say that now we can give the value of, so we can give T1 is equals to RC into logarithm of Vsat. What is our minus Vsat into R2 divided by R1 plus R2 whole divided by Vsat minus of Vsat into R2 divided by R1 plus R2. What will get? So we are assuming that, assume beta is equals to R2 by R1 plus R2. Getting T1 is equal to RC logarithm of 1 plus beta into 1 minus beta. So we are getting T1 is equals to resistor capacitor into logarithm of 1 plus beta divided by 1 minus beta. So T1 is nothing but we can say it has so we can say T is nothing but 2 into RC.